All right, we're live. Hello, everyone. Apologies for the slight delay there, having some technical difficulties. But great to have you back again. I am Solomon Lederer, co-founder of Blockmatics, and I am here with Gregory Rigano, who is our legal expert. And we're going to...
But you can't say expert.
Oh, you can't say expert. I failed on that side twice in a row.
Yeah, you definitely can't say expert. Sorry for the lighting, by the way.
We'll get that's the other issue. We've been working, so we're in a different room than we're usually in, or at least different from the one from last time. So the lighting caught us by surprise. So we are, well, just to give you just a little bit of a background, Blockmatics, we are a education and training company in the blockchain space, where we do courses for non-developers, for people trying to understand the technology, what they can build on it, obviously courses for developers. And then also we'd like to put a lot of attention and focus on the legal side of the legal arena, because there is a very strong overlap between law and what is now happening in the blockchain space. And even the term smart contracts right there, you're talking about contracts. Although there are a lot of differences. So last time we were talking about an ERC20 smart contract. This is like a very popular token contract that is on the Ethereum blockchain that a lot of crowdfunders use, and that is people are issuing their own crypto token in exchange for Ether. Usually it's in exchange for Ethereum coins. You then get some other crypto token. So what I want to point out is that a lot of the operations and things that you're doing on the Ethereum blockchain is simply happening within a piece of code that is on the chain. So in the case of an ERC20, even if something as simple as if I am transferring, say, 100 tokens, let's say Omise Go is a popular ERC20 token. If I transfer 100 Omise Go tokens from myself to Greg, in Greg's Ethereum address itself, it doesn't show anywhere that there are 100 of these tokens. The only place where it's listed or recorded that his address has those tokens is in the smart contract that manages the whole Omise Go network, or all the Omise Go tokens. So in that contract, there's just a ledger which has everyone's address, and next to that ledger there is an associated balance. So if I'm sending him 100, it would just decrement, it would debit my balance and increment or credit Greg's balance, and that's all it is. All the functionality is happening in that smart contract.
So what does that mean, though? So
yeah.
So to a non-developer, to just a regular layperson, they see that now they've received these OMG ERC20s, and it has this value, whatever it's currently valued at, multiplied by however many have been credited to their account.
Yeah.
So they think they own these tokens. They own the private key that now controls these tokens.
Yeah. So in a practical sense, it doesn't make a difference to the end user, because in a practical sense, you are now the only one that is able to control those tokens or move it or send them on to someone else. Because once it's recorded in that program or that smart contract that those tokens are now associated with your address, only your address now has the ability to forward them on to someone else. So in a practical sense, you're still the owner, but this does change things maybe from a legal perspective on what does ownership really mean, because it's not like it's not like these tokens are sitting in your pocket or in your wallet. It's not like you have some dollars, let's say even in your bank account, that are somehow associated that is definitely that you are the owner of it. It's more like there is something out there in this computer network that only you can control. that only you have the ability to manipulate or access. And the reason why we're getting into this conversation or bringing this up in the first place is because what happens if somebody just cuts off that access or cuts off that ability? So up to this point, you're the owner because you are the only one that can control it. And now what if somebody breaks that, breaks that pipe or breaks that access point? It's almost like if somebody were to stop you from ever getting to your safe deposit box. They put every possible obstacle in the way to make, there's this big moat now between you and your safe deposit box. Is that theft in that sense? Not only that, but if they make it, if it's something happens so that nobody can get access to that safe deposit box, is that the same as somebody actually breaking into your box and taking the money out?
So basically, so if you have $20 in your pocket, you have, a $20 bill, paper dollars, and you physically hold it, right? Mm-hmm. But if you have $20 in Ethereum, in Ethers on my Ether wallet, my crypto MetaMask, you're not actually controlling it. It's, part of a code base, part of a network, right? Mm-hmm. And what we have seen historically is that, while there's about $1 billion of Ethers settled in transaction volume every day on the Ethereum blockchain, there have been bugs, and we can cite the DAO for this one.
For sure.
There's also been parity situation, and there have been a few other ones as well. So the point is that essentially who's liable in this situation, right?
Yeah, and just to, I guess to break that down a little bit in terms of who's liable. So, we're talking about getting access to those coins or whatever tokens. So now what happens? So in the case of, which has happened with parity, they're just creating some almost like a wallet for you. Like they're the ones creating the safe deposit boxes that are just out there on the network. Like they're creating the code so that you can generate essentially your own safe deposit box. But there was a flaw in it, and someone was able to sort of essentially lock all those boxes.
Right.
And now no one can open them up.
So it's not like they were essentially stolen, which was the case in the DAO, right?
Right. The DAO is more of a straight up theft. But even there, we can make some distinctions. How that differs from actually taking money out of your home or wallet. But we don't even have to get. There are definitely a lot of nuances there. But in the case of where you're creating some kind of application or wallet that other people are now using, that is then So what's interesting in the parity one, no one even took anything. They just blocked your ability. They just broke it or burned it. So it's almost like someone destroyed your property.
So why don't we back up and talk about like how both the DAO and the Polkadot parity, those hacks, how they happened, and where they started. So with the DAO, so as you may or may not know, so the DAO was at the time, I believe, the most successful crowdfunding operation of all time, when approximately $150 million of Ethers were raised. Mm-hmm. And this was when the price of Ether was like $10 or so.
Right. Yeah, I think it was a $14
give or take.
Yeah, actually, I do remember this. I remember Ether had spiked to $14. I don't know exactly when what the price was when people were contributing, but you're right. Probably was around 10, and it went to 14 or even 17. Actually, it kept going higher. There was a short spike to 20, and then with the DAO hack, it just crashed back down.
So the DAO was essentially, it was an ICO to basically create a venture capital fund that anyone could buy into. We're not going to go into the legalities of that right now. I'll save that for a different program.
Yeah.
And the code to raise the money and hold the money, or the ethers. So they raised 150 million in ethers, and then they never cashed it out to US dollars, right? It sat essentially in a multi-sig. Is that correct?
Yeah, right. Essentially, it was in. Yeah, you can think of it like a multi-sig. So you need a lot of operators in order to move any of the money.
And what a multi-sig means is essentially a multi-signature smart contract where you need multiple accounts, private keys to sign off to move any of these ethers, right?
That's right.
And in this multi-signature smart contract, a malicious actor was able to penetrate it without getting the requisite number of private key signatures. So instead of, say, it needed 7 signatures to move any of the ethers, he was able to penetrate the code base, however he did that, and start sucking out funds, start to suck out the ethers.
Yeah,
right?
So in the DAO one, they had this ability. So so overall, it's almost like you had this big crowdfunder pool of money, but you're able to then create another, like a child crowdfunder, where other people can put money into. So you can spin off. You could spin off your own little crowdfunder. And you can withdraw, essentially, you can move the funds that you had in the parent one into a child one. So it gets really complicated. What happened was the hack was that the person creating this sort of like child or the sub crowdfunder was able to withdraw their funds repeatedly again and again and again. So the overall, like the master contract was not accounting for a scenario where there was like this recursive withdrawal. So in the process of the withdrawal—
Can you explain recursive quickly?
Yeah. So recursive is where you execute an operation, and that operation goes to back to the first step. So it repeats the process over again.
So it's like a loop.
It's a loop, but in order to solve its problem, so I don't know, should we get into how technical? So for instance, if you want to know what is well, I don't want to get into like what a Fibonacci sequence is, but
I think you should.
I should?
I think you should.
Okay.
It'll pique people's interest. There's Wikipedia. Everyone could read the first paragraph on Wikipedia about Fibonacci and
okay, there we go. Code. So quickly, a Fibonacci sequence is every number is the sum of the previous 2 numbers. So if, let's say, you start with 0, 1, the next one will be the number 1, because 0 plus 1 is 1. And then after that would be 2, because 1 plus 1 is 2. If I had a board here, it'd be easier. And then you get
there's 3. One right there.
I know. But you can imagine, if you can do this at home, you write out 0, 1, 1, 2, 3. After 3 comes 5, because the prior 2 numbers is 2 and 3. You get 5. And then you get 8, 13. And then 8 and 13.
All right.
We get the idea. Right. So each one is a private. But if I were to have a program and I want to know what is the say the 10th Fibonacci number, what I can do is I can have that. So I tell this program, hey, give me the 10th Fibonacci number, meaning the 10th number in the sequence. So recursion would mean that this program would be like, I know what the 10th number is. It's simply the sum of the 8th and the 9th number. So this program, in a sense, calls the operation on itself with saying, I want the 8th number and the 9th number in this sequence. And then the program gets saying, oh, okay, I need to figure out what the 8th one is. I know what the 8th one is. It's simply the 6th and the 7th added together. So it's invoking itself repeatedly in order to get this end solution. I realize that it takes time to digest and what's happening, and it's a lot easier, obviously, if you write this out. But the idea is, again, you're in the process of coming up with a solution for what you really want to do. You need to call yourself or invoke whatever your abilities are on some smaller elements of the problem.
Do you want to write this out?
I don't think it's really worth spending more time on it.
Maybe for the next one.
Yeah, for the next one we could call this out.
So,
so the point is, in the process of withdrawing the funds from the big Dow contract, the user was able to call the big Dow contract again and again before it really updated the fact that this person already withdrew the funds. So it was able to, over time, keep siphoning out more and more money to the point where there was $60 million worth of Ether siphoned out into this child contract, where really that person maybe only had the ability to really siphon out, $1,000, which was their own money, but they kept siphoning 1,000 repeatedly again and again.
What do you mean by being able to siphon out $1,000?
So the person was legally allowed to pull out some money because they actually did have some money in the big master Dow contract. But the master Dow contract was not recording the fact that this person already withdrew the money, because the whole withdrawal operation wasn't really done. Like the last step of it wasn't really recorded. So, but before that last step was recorded, this hacker realized that there's a way to call the master contract again to withdraw your funds. So essentially you're withdrawing, it's like you go to the bank and you're saying, okay, I want to take out $1,000, and you have $1,000 in your account. But as they were giving you the money, you turn to another teller and say, hey, I want to withdraw $1,000. And the first teller didn't yet record that, hey, your account is now empty. They see, oh yeah, you have 1,000. So they gave you 1,000. And then you can turn to another teller.
And you go to like 10,000 tellers.
Right, 10,000 tellers. And then the bank wakes up and like, what the hell's going on? Our reserves are just being, somehow $1 million got pulled out.
Or like 60.
Right, or 60 million in this case. Yeah.
So in the analog world in a bank, that would never really happen, because you'd have to go to 60,000 tellers to get $1,000 each time to get $60 million. So that's like impossible.
It's impossible. And probably before they even hand you the money in the first place, they need to record and say, they'll record that your account has 0 in it. So maybe it is possible all those tellers, they have the money ready, but then one of them will then record. Yeah, I don't know, but you can imagine really the problem is you need to finish this process before somebody could.
Solomon's planning a bank heist live on Google Hangouts right here. So the point is that this code base was deployed and there were bugs in it. It wasn't secure. It wasn't super secure, right? And this is why Bitcoin is so damn impressive. I believe the Bitcoin code base has only gone awry one time in like 2011, in which
I think there was
like 100 million Bitcoins printed or something crazy.
Right. There was one, that case where you had all these Bitcoins printed, and then there was also once an issue that the chain forked unintentionally.
Right. So the difference with Bitcoin is Bitcoin's a decentralized architecture. No one knows who started it. It wasn't an ICO. Whereas in the case of the DAO, it was an ICO crowdfunding operation in which, people were put their names to it, and, they were essentially running the operation, and now a third of the money kind of disappeared. And this is what resulted in Ethereum and Ethereum Classic. We won't get into that now either. Right. But in that situation, so who's liable, right? Who deployed that code base? Who pressed essentially deploy? Like the person who presses like a button to drop a bomb or something like that. Like who pressed it? Is that person liable? Is it the person who wrote the code base that signed off on it, like a consultant would do for any sort of technical initiative where they have to sign off and say, I sign my name to this, or a lawyer issuing a legal opinion when the lawyer says, I sign my name to this, that this is all legal and all that good stuff.
Right. And what if you have also like some auditing agency? Well, it's a twofold question. What if you hire an outside agency to audit it and they say, yeah, it's good to go? Are they then the ones who are liable? Or what if you don't hire some other auditors? Maybe you can be found liable for that. Like, why didn't you go through the steps of getting an auditor? I believe the DAO did have auditors, but in the case of I know in the case of the parity hack, or whatever you want to call it, the parity bug, they did get criticism because I believe that code was not audited.
So I'm going to actually make an interesting opinion here. And, you know, this is not financial advice or legal advice or any other advice in any capacity.
We're just talking.
I don't think these coders are liable. I don't think the engineers, the developers are liable, like hard stop. Mm-hmm. I think they're liable if they commit fraud in any capacity, like saying invest here, make 1,000,000% return inside of a month.
Right.
And, you know, this is going to cure cancer. I think they're liable if they commit fraud. But I don't think they should have liability in deploying cutting edge software code to really push the limits on crowdfunding and global commerce.
Right. And as a layperson, that makes sense to me, right? So like common sense, you would think, especially since they do always put on their website or that this is open source code under the GPL license, and you know this is all in your own hands. We're not, you know, they have all that typical, I guess, language that you would put.
If you look at the parity Polkadot, maybe you can pull it up on a screenshot here. Mm-hmm. The Polkadot offering document, if you just Google that, and it'll say memorandum Polkadot, they have a whole list, like a very long list of risk disclaimers that basically say you are a crazy person for buying into this, and anything just short of you dying, in which you give us your ethers or money, can potentially happen, and more or less we are not liable. So that's how they kind of cover their backside. You have Polkadot offering documents.
Yeah, trying to pull that. Okay.
It's one word, Polkadot offering documents.
This is memorandum?
Correct. Yeah, you could just click on that.
Okay, and I'll just have to share the screen here a sec. Let's do it. So in the what happened with Polkadot, which I believe was by the Web3 Foundation, is that right? Yes, Web3 right? Technologies Foundation. Such a good name, Web3. They really did a good job with that. So yeah, if you scroll down, scroll down a little more. Scroll down a little more. Risk factors. Okay. So it just kind of goes on and on and on about, you know, how risky this is, and this nothing may ever happen, and you know, you're crazy to essentially give us your money, which, you know, they are really pushing the limits. Gavin Wood recently at the Web3 Summit in Berlin last month, he opened up a brand new computer and deployed a blockchain within 60 minutes. Oh, you didn't see that? Or 60 seconds? Or no, in 60 minutes, within an hour. Deploying a blockchain in 60 seconds is a little nuts. I don't think we're there yet. Well, but you can. I mean, maybe they had some like special.
You can deploy a blockchain in 60 seconds?
Well, a private one, well, you definitely a lot faster than 60 minutes. So we do this in our classes actually all the time.
You deploy your own blockchain.
On Microsoft Azure, you can, or any cloud system, but you don't even have to do it on a cloud system. But in our classes, we do it on Microsoft Azure, and you're up in like 10 minutes. You have your own blockchain. I mean, it's really, to demystify it, a blockchain is really just another networking program, so, or a database even. So if you can deploy the database in 10 minutes or so.
So you've deployed a public blockchain?
So those are private ones, but there's no difference. I mean, we can run it on my machine, and then you could start on yours, and we can connect to each other, and it just takes a few minutes.
We should do this live.
So well, we can do that next time.
Yeah, I think that's
so. Gavin Wood, maybe he was doing something else but he wasn't on stage for 60 minutes.
Yeah, he was. Yeah, he was doing it live, and it was like a whole. And like CoinDesk covered it. It got a lot of. So Solomon's basically saying that. You know,
if you wanted, I'll stop the screen share unless.
Maybe you are on the same level as Gavin Wood.
No, definitely not.
No,
I'm not gonna say that. No way.
So what happened with?
I have another question for you.
Okay, go ahead.
Well, unless tell me if I'm jumping ahead, but you're saying how, yeah, I agree. The developers are not liable, but there's still a lot of other. What happens in a case where I am some investor? You give me, I don't know, you gave me, let's say, $50,000, and I go ahead now and invest it or put it into whatever, some token or some ICO, whatever, that is now stored. That money got stored in one of these flawed contracts that got hacked or broken, or let's say it's in a multi-sig, or the parity multi-sig. That money is now lost. I guess presumably I'm still responsible to give you your money back.
So who are you and who am I in this hypothetical?
So you're a regular guy, whatever. You're some rich dude who wants to.
I'm a rich guy.
Yeah,
looking for the next 1000x.
Exactly.
So I can't stop.
So
I'm addicted.
I'm a hedge fund, let's say, and I'm a crypto hedge fund. You give me the $50,000.
So you're a fiduciary to me. You have a fiduciary duty to me to make my money grow, but you got to protect me.
Right, but now this bug happened, and maybe I even stored the tokens that I bought for you or on your behalf, or that investment.
You invested into an ICO.
Yeah, and maybe it was like we had an arrangement where it's a direct thing. Like you specifically say, okay, here's money specifically for, you want to buy, I don't know, a BAT token or Polkadot. I think it was Polkadot was also using the like they had their own ICO, which was using the parity multi-sig contract, and now that money is gone. So
well, it's not gone, right?
It's
just frozen in time.
It's frozen, right? And by the way, I think it was something like 500 in the case of the parity multi-sig thing. There was 500 other contracts that were using that like parent contract. So what happened was over there is like parity made this kind of the base contract that had a lot of the functionality, and then each individual organization or person can then deploy their own smart contract that it rests on top of it. You can think of it. So it was one that was using the actual engine or the parts of the parity contract. So you gave me this money. I got these tokens for you. I'm storing it in this contract, and now you can't access it. Do I say, hey, the tokens are there, I got it for you, you can go take it? Or you're like, no, what do you mean? I just gave you $50,000.
So this is where the level of sophistication comes in. And what did the shrink wrap say? Mm-hmm. So, shrink wrap, which is like those, like when you buy Microsoft Word and you have to agree to the end user license agreement. Like I read it because I'm just a crazy lawyer, right? Some other people may or may not read it. So shrink wrap has been determined to be sometimes unenforceable, but it's only unenforceable when it's kind of egregious. Mm-hmm. So when it's saying like, by using Microsoft Word, you agree to give us all your money, and now we have the mortgage to your house. You have signed by using Microsoft. Right. Like that's egregious, and that would totally not be enforceable. But if it's in the parity Polkadot situation, and they have a whole list of risk factors that say, the Polkadot blockchain may never launch. Ethereum is, very cutting edge, and it has been susceptible to bad things happening to the ethers and money, and this could happen in this situation. And you, as the hedge fund, and me, I'm a rich guy in this situation, right? Mm-hmm. So I'm an accredited investor. Did you show this to me? So it's a weird. It's like legal weird stuff,
Right.
So
I had to make you like very aware.
Yeah.
Like, these are the
devil in the details. Did you say to me, "Oh, we're gonna invest in this new blockchain, and look, the price has gone up from 2008 to now 100,000%."
Right.
Don't quote me on that, but I think that's the number. 100,000%. And this is the next thing that's going to go up 100,000%. Did you commit any level of fraud against me? Did you prey on me? And like, am I a rich guy, but I'm old and I can't hear good, and I'm like a little senile?
Well, let's say you did everything, but right. So maybe I didn't try to pull anything over you or over your, whatever it's called, the wool over your eyes. But
so you're saying it's in good faith everywhere?
I behaved in good faith, but you can still have a claim and say, wait a second, why am I putting all that tokens in that open source? Why am I using that parity contract when they say point blank on their website that, hey, this is still early technology? But I guess maybe I need to then relay that info to you.
So this is where it gets really interesting, right? I truly believe that the accredited investor status shouldn't apply to blockchains, because in order to really invest or contribute funds to blockchain projects, it doesn't matter if you're an accredited investor or not. Right. There's a technical and legal hurdle, and maybe even financial, that you need to cross to go into this world to really understand what the heck is going on. If you're an accredited investor, like, so what? Yeah. Like you probably 99% of accredited investors have no idea what UTXO is, how Ethereum works, this concept of addresses, essentially decentralized databases, how this came up from the underground, and like you're not trusting corporations in any capacity. You're trusting open source coders, that the foundation is on an anonymous person or group of people and Satoshi Nakamoto. Like, this is all. That's
a great point.
This does not fit into the traditional square hole that is SEC accredited investor. It's something totally out there. This didn't come top down. You know, this came bottom up.
Right. So yeah, when you say that, it made me realize, like, why am I just focusing so narrowly on this parity contract? I mean, what if the whole blockchain goes down, which could happen? I mean, there could be a bug that's systemic to the whole system. And let's say you said, oh, I want to invest in, I don't know, Zcash. And I don't want to pick on Zcash. Maybe I shouldn't name names. But let's say, I'm just saying.
I'll stop you before you cause any issues.
I'm just saying, you have a lot of these cryptocurrencies. It's a separate blockchain, and it's not Bitcoin, it's not Ethereum, or, I mean, those can also go down, obviously, but you just put money in one, and now the whole thing is gone. Obviously, if you told me, or you knew you were investing in that, so I mean, there's no way I could have, like, me as the hedge fund, there's nothing I could have done any differently. There's no way I could have saved you. But I guess in the parity one, I could have maybe been better by using maybe a more vetted contract, if there is one. But it kind of had broad community acceptance. So yeah, it's hard to say I was being negligent.
So the difference in the parity Polkadot situation is, and the DAO, is that the DAO was, I guess, evil in some form or another. Right,
the hacker.
Yeah, because the hacker was intentionally siphoning funds, whereas in parity Polkadot, it was actually just a guy testing out smart contracts, and he was sending bombs to. Well, this is what it said in the memes and stuff. He was sending. He was essentially testing out smart contracts using the Polkadot ICO or multi-sig, trying to kill them, right? Like kill switches. Is that what was going on?
That was it. Yeah, he tried to there is a kill switch for contracts if you're the owner. He was able to assign himself the owner and then kill it. So, there was this screw up where when this contract was initially released, that it should have really set the parity as being the owner, but that was never got set. So it was just open for anyone to take it. It's open for grabs for anyone to set themselves as the owner. But you're right, yeah. So that in that case, it was this developer, by the online. His name was DevOps199. And he said, hey, I'm just a newbie. I'm playing around. It seems like it could be the owner and kill this contract or something like that. He said some message like, oops, I accidentally kill it. But it seems like he was trying. Now, how malicious was it? It's still hard to know.
Right, but
whether it's just like playing around. And
but isn't it okay to try to kill a contract? Isn't that, if you're not intentionally trying to steal money and you're just trying to test the security of something, isn't it okay? Like, isn't that the whole point of like open source software, is that it's secure? And isn't that what makes Bitcoin so incredible? It's that it's 500x the processing power of all the Google servers in the world. And there's essentially $100 billion bounty on Bitcoin if you can do it. And no doubt people try to do it every day.
Right.
So that's like why it's so impressive.
It's okay. So right.
I mean, this is the weird intersection of,
you could say, he was doing a service.
Right, like high finance. And like, what if this happened 5 years from now when this whole security token op craze, probably takes off, and then it happens then.
Right.
And then what?
Well, by the way, people say that about the DAO hacker too. That's why there was a lot of support, or a lot of people that were not really behind the DAO hacker, but saying, well, hey, the person was still following the rules, meaning as they were written, maybe not as they were intended, but that was the rules of the contract that allowed for that. They were able to slip through, and maybe that is just showcasing. Maybe that was good for the ecosystem as a whole to show, hey, it was $60 million this time, but maybe people shouldn't assume that, hey, this thing is so rock solid that maybe in the future there'll be a smart contract that has $500 million in it. Or actually, in the case of the parity one, overall, at the time, it was something like $250 million worth of Ether that were just wiped out. It was about 500,000 Ether tokens.
Well, you can still see it, right? It's just frozen.
It's right. You could still see it, meaning all those contracts still have those balances associated with it. What was removed was the actual withdrawal function was deleted, so there's no way to withdraw it. So the only way now to get it back is that there have to be an update to the whole Ethereum network overall to either restore that code or to have some other ability to get access to those.
So this is really interesting, right? Because there's an Ethereum improvement proposal, EIP, to make that happen. Right. And it's like kind of splits the community. Because some people say, no, we can't go do the DAO thing again. It's got to be immutable, and such is life.
Right.
But when the DAO happened, it forked into Ethereum and Ethereum Classic. So I believe the EIP is not calling for a fork. It's calling for.
Sadly, I don't know. I haven't been following I know there were a few proposals, and there was one proposal that was then rejected by there was some sort of, I guess, unofficial poll. But I don't know.
Could we get into that though? Who makes the decisions to integrate EIPs and not? Because this plays a role in like, I don't want to be the lawyer, right? That it's like tells on people, and it's like, oh, this is a security for this reason. But so EIPs are Ethereum improvement proposals, and same thing with Bitcoin. We can get into that as well. And BIPs are Bitcoin improvement proposals, and it's basically their proposals to, try out interesting things or upgrade the software or the network that is Bitcoin or Ethereum. And it's not very well known who decides to put these things through and who doesn't. Right. And the defense that these people that have this power to make these decisions, what they say is, so we're going to make these decisions, whatever. And if you don't like it, it's open source software. You're free to go fork Bitcoin or Ethereum whenever you want. What it really comes down to is, so these blockchains are like religions. And they only have value because people say they have value.
I hope they're not religions.
They are religions. Like, why does Bitcoin have value? It only has value because people say it has value. Same thing with Ethereum. Like, they allow you to do things in society that are good, but like...
That's true. We have a lot of these collective understandings or agreements that it's really just a human conception or just something we all made up. That's true. I mean, even the idea of like a corporation, and to some degree, is like
it's a story.
I mean, it's a story, right? It's pieces of paper. We say, oh, it's legal. I mean, law is a story, right? So
yeah. So if you fork the bit, there have been like, we'll just estimate about 100 Bitcoin forks at this point, and there's only 4 or 5.
Many,
I don't know. It got out of control in like 2017, right. But the great majority of them, like 99% of them, no one believes in them. Their story is no good, so they essentially don't have any value.
Right. I mean, the same goes with like a lot of government currencies. Like once the population stops believing in the government or their ability to, or the economy overall, then the story of their paper money just also goes down the drain.
So who's making the determination to integrate Bitcoin improvement proposals or Ethereum improvement proposals into the, and then are they liable if anything goes wrong? This is why, so like Bitcoin hasn't had a hard fork in like over a year, right?
Yeah.
And this is why it's kind of like, maybe you don't want to. Maybe you don't want Bitcoin to do anything. Bitcoin has the Guinea effect, they call it, right? It was the first one, and it's now, it's the story in people's minds, and it's the more it becomes digital gold, and they talk about it on CNBC as digital gold.
What do you call it, the Guinea effect?
A Guinea coefficient, something like that. Or maybe it's like Lindy. I'm just on Twitter too much. It's like these hot, like historical math terms about like where money came from.
Gotcha.
Point is, though, is that who's making the decision to integrate, who's making the decisions to put out smart contracts, to issue money on a blockchain, to upgrade the software, right? And what are the liabilities here? I am of the opinion that these people should not have any sort of financial responsibility, because they're not, unless they are committing fraud. They are totally pushing the limits and like breaking down barriers for like global commerce, so that communist states like no longer have power over their people, right? So like the benefit to society, in my opinion, like significantly outweighs any detriment, like the DAO hack or frozen ethers.
But yeah, I mean, honestly, I think actually this is a really good topic for us to talk about next time.
A lot of next times. We got 3 different topics for next time.
We do. Now. I thought this was the so I think this is a really great area to discuss separately in terms of how does governance of the core protocol work for different blockchains? How does Bitcoin compare to Ethereum, which maybe compares to EOS or Tezos? And maybe some of those structures, you could say in that scenario, the developer is more responsible. Maybe in the case of EOS, where they're, again, I don't want to point any fingers or pick on any blockchain yet until we actually get into it. But maybe some of them are structured in a way where the developers or the foundation that manages it is more liable versus other ones where it's a far more kind of ragtag team around the globe where it would be harder to really peg as someone as being responsible.
So on that, we are in the midst of a hostile hard fork right now. I don't know if you've been paying attention to the Bitcoin Cash situation.
I have not. I mean, I know that it is going on.
So,
and again, I know we just have.
So we have 10 minutes left. So I would like to address this as maybe like because it talks about, so it's a battle between 2 software development teams, governance, burning of coins, and kind of where it's going to go. And if there's not replay protection on either chain, it could result in like lost coins or it not being honored, and like who's liable in these types of situations. Unless there's something else you wanted to get into. Did you have any other questions?
No, and I think we're pretty much. I think we're 50 minutes in at this point, and So I mean, feel free to.
So
go ahead and.
So there's so Bitcoin Cash is a fork of Bitcoin from November 2017. We actually had an awesome blockchain and law panel about it last year. And so Bitcoin Cash is trying to be peer-to-peer digital cash, whereas Bitcoin, hard stop Bitcoin, is more of a store of value, right? So, and Bitcoin, hard stop Bitcoin, call it Bitcoin Core. I'm not going to call it Bitcoin Core.
Just say Bitcoin.
They are implementing Lightning Network, which is a pseudo centralized solution to make Bitcoin have its peer-to-peer cash operation happen, whereas Bitcoin Cash has very large blocks, and they want to make the blocks even bigger, such that it is peer-to-peer cash, but they also want to implement a smart contract platform on top of it. Are you aware of this?
I'm aware of the smart contract platform, yeah.
So the argument there is it could scale. Like essentially the fees would be close to zero, giant block sizes, like over 50 megabytes. Craig Wright wants to make it 128 megabytes.
Oh, is he involved with it? Okay.
So it's nuts. So there's Bitcoin ABC, which is supported by Roger Ver and Jihan Wu. Roger Ver is known as Bitcoin Jesus.
This is another whole conversation. By the way, I do want to finish the thought, and then maybe we should just see if there is any questions out there. By the way, we should point out if there are any questions, you can put them now. I think we just have like another 5-10 minutes. But yeah, getting back to your
there's Jihan Wu, Roger Ver camp. We'll just call it Bitcoin ABC, and there is Craig Wright, who claims to be Satoshi Nakamoto camp, and that he calls it Bitcoin Cash, Satoshi's vision. So they are very opposed to each other right now. And on November 15th, there's going to be a hard fork in Bitcoin Cash.
Next week.
Next week, right.
Wow, so it's good we are talking about this.
And the two camps like really disagree on what's happening. Craig Wright wants to make the block size go up to 128 megabytes.
I thought Roger Ver and Craig Wright were friends, but
they recently, well, at least on Twitter, they're showing that they split. You know, part of me thinks that this could be like, all made up to make the price go up higher because
they'll come back together or something. Yeah.
Something like that. So we're in this really weird place where you have two entities that on one blockchain that are supported by billionaires. One wants hard fork A, another one wants hard fork B. Both essentially want the same thing. Both want bigger block sizes for smart contracts so that Bitcoin Cash could run in a way like Ethereum. But Craig Wright wants his block sizes to be essentially double the size that the other group of billionaires wants.
So that alone, just that double size, is causing the whole rift.
Right.
Yeah,
so
I have to look at
So it's unknown what's going to happen when this fork happens. Craig Wright has said that I'm not. So they're both going to run two chains like separate. So it's unknown if there will be two coins that come from this. And what we know today is that it will be a hash war. So whichever one comes out being the longest chain.
Yeah.
But that is like, how much money are you going to be willing to burn to become the longest chain, right? Because whoever loses is going to lose probably hundreds of millions of dollars if that happens, because you have to mine the chain, right? So you have to bring your own miners into the equation. And then if that happens and people are transacting on the losing chain.
But presumably there'll be enough.
Right, but in this time, right, but if there's not two coins, right, and there's just one Bitcoin Cash, and you transact on one chain or the other before it's determined, before someone gives up, right, or before the longest chain is determined. And so, like, do you lose your coins like that? The block, if there's not two coins, what, like, do you understand what I'm saying?
Yeah, I see what you're saying. If there's not enough, well, if I understand correctly, if
like it screws up the chains, it screws up the transactions on one chain or the other.
Because normally people don't realize this, that there are forks happening all the time in the Bitcoin network. But what happens is, when I say a fork, meaning that there are two blocks that get published about the same time that are in contradiction with each other.
Right.
But what happens is the chain automatically self-corrects, because the rule is the longest chain always wins. You may have heard this. Yeah, the longest chain always wins. So that even if there's a part of the network, once one version outpaces the other, so if, let's say we have two blocks, we have block 11A and 11B. They're both equally valid. They both follow from block 10. They're both valid. So we have now a fork. But what happens is either 12A or 12B will get created first. Now, whichever of those two have, let's say 12A gets created first, everyone who's on the B side will be, oh, wait a second, there's a longer chain. There's, we got this A is up to block 12. We only have block 11. So they switch over automatically to the longer side, because that's the rule. But now I think what you're describing, if I understand correctly, you're going to have a situation, they're different, but it's not just that they're different on the actual history, which is what happens normally all the time, but they're actually different in some of the rules that they're following in the protocol itself. So you can get into this really messy scenario.
And a major issue here is that because Bitcoin Cash now, they're trying to make it peer-to-peer digital cash.
Mm-hmm.
There's like services that offer transacting in Bitcoin Cash. So
now they have to support both. Yeah.
These like bodegas, right? That are accepting.
How many bodegas?
I don't know. There's definitely at least one bodega somewhere in the world.
Yeah.
That's supporting Bitcoin Cash, right? That accepts Bitcoin Cash, maybe
Mm-hmm.
in Japan or somewhere else, what have you. Which blockchain, like, what's going to happen?
Right. Hold on, I just got to pause this. Yeah. Yeah. So I guess we'll see next week.
So usually like the longest chain always wins out, and it's like economically incentivized to just go with the longest chain. But now you have two billionaires on each side that are basically saying, I am willing to burn money like the Joker in Batman to make my chain longer. So it's like, who mines it fastest?
Mm-hmm.
So this could also actually cause a hash power situation where a lot of the Bitcoin hash power goes to Bitcoin Cash, because it's going to be like incentivized to do this.
Right, so now we're having really three competing. We already have this Bitcoin versus Bitcoin Cash competition to some degree, and now we're going to have this Bitcoin ABC.
Well, we don't know if two coins will come out from it. I think ADC is implementing replay protection. I don't know. But taking it further, so what if this bodega, like, will its payments not go through? Will it get screwed up because of the chains? And then who's liable for this?
Oh, that's an interesting question. And who is even liable for starting all this? Okay, we have a lot to talk about next time.
But then if they do make it two coins, right? So does the bodega, like, when they're accepting payments as this chain split, and who's going to be the longest coin, and someone buys a coffee at the bodega using Bitcoin Cash, what blockchain does that go to? Right?
Yeah, I mean, so I guess that depends.
So it's who's gonna seed first and say, this is Bitcoin Cash, and that one is Bitcoin Cash, right? It's like a really weird thing.
Yeah, I mean, if there isn't replay protection, what can happen is, I mean, obviously it depends on the point of sale app or whatever the app or wallet that the merchant is using, which blockchain they're talking to. But just explain, replay attack or replay issue is like when you send a transaction to the blockchain, or you're sending an instruction, hey, debit my account and credit someone else's, even though you're broadcasting that to, let's say, Bitcoin Cash nodes on the Bitcoin Cash network, any of those can take that message and say, hey, I'm going to broadcast that out to nodes that are on this other blockchain network. And everything will work the same, because essentially that digital signature, that instruction, is equally valid on that other chain, and be like, oh yeah, this person authorized this transaction. Even though they initially only broadcasted it to one chain, someone can take that message and broadcast it. It could even be accidentally, can somehow make its way to get broadcast to another chain. So that's why they need to actually, when they do replay protection, they change something in the format of the message itself in some special way so that it cannot be, that one chain will just not recognize it or won't honor it, or it cannot be honored on another chain.
And that's what happened with the Bitcoin and Bitcoin Cash.
Right.
Fork is that Bitcoin Cash implemented replay protection, right?
That's right. So even in the whole structure of the message or the header of it, the metadata with it is different. So either chain would not honor, right? So Bitcoin will not honor a Bitcoin Cash transaction and vice versa.
Yeah, I think we'll leave that for now. And maybe we'll cover this before the 15th next week.
Yeah. So two things. Right. So you mentioned the 15th. We're going to talk about, well, you're right. For the 15th, we already have an agenda planned. We're talking about the EOS or EOS token sale, which is by far the biggest token sale of all time.
The greatest crowdfund, I don't want to say the greatest because that means that it was the best.
So great. The largest.
Yeah. The most money ever raised in crowdfunding campaign, depending on the price of Ether and when they sold it, upwards of $4 billion. Yeah. So how do they do that? A legal and technical analysis. We will be bringing that to you next week. Yeah.
Right.
November 15th.
After that, December 4th, let me just check the date one more time because I know that was
December 4th. Yeah.
December 4th, 9 a.m. We're doing a CLE
continuing legal education course.
That's right. It's going to be 9 a.m. in New York City. So any of you that are in New York, you can actually come. We're in West Soho. We're going to be holding the class. It's an hour-long class, and you get CLE credit for it. So you get some knowledge more on smart contracts and a lot of the legal elements around
where it
tokens.
Right. So like FinCEN analysis, KYC, AML, which is obviously always a very big deal. The company called Blockchain is airdropping $125 million of Stellar Lumens on blockchain wallet holders, but you have to do KYC, AML first. We see decentralized exchanges now having to implement KYC, AML, which that begs the question, are they really decentralized if that's happening? So FinCEN analysis, Financial Crimes Enforcement Network, OFAC, Office of Foreign Asset Control, SEC, Securities Exchange Commission, Bill Hinman, who is a high up official at the SEC. I believe he's a director of one of the finance groups. He is at Georgetown FinTech conference today and yesterday. And he was talking about information asymmetries in ICOs and how if there is information asymmetry between the promoter, developer, and the contributors, it could be construed as a security. We will go into that. CFTC, Commodities Futures Trading Commission, which is what EOS really leveraged. They basically made their token, they commoditized software bandwidth. And we're going to be going more into that. So yeah, the CLE is really a comprehensive course on all the US and even some global regulations.
We cover some global stuff too. All in just 1 hour. So you get in and out you're out by 10 a.m. and still head over to work. All right, until next time, follow us on blockmatics.io. You can check out our blog, follow us on Twitter, all that stuff. And we always post articles on the latest of what's happening in the blockchain space, and also tweeting different articles that other people are writing that we find really interesting and relevant. Have a good one. Take care.
All right, signing off. Thanks for tuning in.